The elevation of a line capital AB 90 mm long is inclined at 30 degrees to HP and measures 70 mm. The NDA is 20 mm above HP and is in VP. Draw the projections of the line and define the inclination with VB. So this is the problem. So he says the elevation means the front view. The front view of a line capital AB 90 mm long is inclined at 30 degrees to HP and measures 70 mm. So that means he has given the true length and the true inclination with respect to HP, and also he has given the front view. The NDA is 20 mm above HP and is in VB. So first we are going to consider the NDA. NDA is 20 mm above HP. So when you look from the front view, it will be when you look from the front view, you can see the distance above HP. So that will be seen on the vertical plane. So from XY line, you measure the distance of 20 mm and mark this point A dash. And NDA is in VP. So when you look from the top view, the point is in VP. So obviously the image will going to be seen on the HP. So that point will going to become small a. And the true length of this line will be 90 mm long. Is inclined at 30 degrees to HP. So first we are going to measure a 30 degree line, and with A dash as center, draw a 30 degree line to a length of 90 mm. So we will going to get the locus in the front view. So once you get the locus in the front view, we know that the front view measures 70 mm. So here, since you know the length of the front view, with A dash as center, take the radius of 70 and cut an arc and join A dash B dash with a dark line. So we have the front view now. Once we have the front view, so the distance between the end projectors, that means the top view of the point B should lie on this end projector. So you draw a vertical projector in the front view, that is in the vertical plane, and then extend the same end projector in the top view. So in the top view, we will not be able to, now we don't have the locus of B. Now we need to find out the locus of B. To find the locus of B, first we have to take the true length in the front view. So the true length in the front view is 90 mm long, that is A dash B1 dash. So since we have this B1 dash, so we can write the locus of B in the front view, and since this is the true length, so obviously this will be capital B1, and since we have B dash, that is the front view, so A dash B dash with a dark line, then join A dash B1 dash with little bit darker than, little bit thicker than the projector line. So since we know that this is the true length in the vertical plane, obviously that line has to be parallel to VP. So NDA is in VP, so B1 should also be in VP. So we draw a vertical projector from B1 dash to the XY line, so that AB1 is the line which is parallel to VP. Since it is parallel to VP, we can see the true length in the vertical plane. But now we have the top view of the point, the top view of the front view true length, which is A dash B1 dash, is AB1. Now, but the top view of the end B must lie on this end projector, which is already projected from B dash. So with A as center, take the radius of AB1, draw an arc such that it will going to cut the end projector here. So that means you are going to get this point B, then join A to B with a dark line. So when you are looking from the top view, what happens? The point AB1, that is A dash B1 dash in the front view, is rotated such that this point B1 dash, that vertical line of the B1 dash, will come on the end projector here, so that you are going to get this distance. So this point will going to form B, capital B, then join capital A to B with a dark line. So this is the actual line in the 3D. So when you are projected into the top, when you look from the top view, it is projected onto the horizontal plane, and when you look from the front view, it is projected on the vertical plane. So you have got the top view now. Now we need to find out the true length in the horizontal plane. So with capital A as center, take the radius of AB, then draw an arc. That means you are rotating the point B such that NDA and NB both are at above HP by 20 mm, because we are trying to find out the true length in HP. So obviously that line has to be parallel to HP. So NDA is above HP by 20 mm and NB2 should also be above HP by 20 mm. So you are rotating the point B such that it will be above HP by 20 mm. So when you look from the front view, when you look from the top view, it has been projected onto the horizontal plane so that it will going to cut on the locus of B at this point. So you're going to get the small AB2. Then join AB2 with little bit thicker than the projector line. So this will going to be the true inclination with respect to VP. So that inclination is shown as phi. Now when you look from the front view, that is projected onto the horizontal vertical plane wherein both A dash and B2 dash is above HP by 20 mm. Since it is parallel to HP, so we are getting the true length in HP. So here we are getting the projection here. When you are doing the projection, that projection is this, and when you are doing this projection, that means you are projecting this. So okay, now once you get that, so since we are rotating like this, so obviously the image will going to be from A dash to B dash with A dash as center. Take the radius of A dash B dash, rotate such that B dash will going to be above HP by 20 mm. Since you are changing the position of B dash from B dash to B2 dash, so naturally this will going to become B2 dash. Then both A dash and B2 dash will be above HP by 20 mm. Since it is parallel to HP, so we are getting the true length in HP. So then you are projecting this onto the locus of B in the top view, because once you get the top view B, so you will go to get the locus of B in the top view. So you write locus of B, since it is parallel to HP, you will going to get this point as capital B2 and you are going to get this as capital A. So this is how we can analyze this in 3 dimension. Now we will go for the writing the solution in the sketchbook. First we will going to draw the XY line and mark VP and HP. So the end A is 20 mm above HP. So above HP is seen in the vertical plane. So from the XY line, you measure the distance of 20 mm and draw a horizontal line. And consider end A is in VP. So consider any point on this horizontal line and draw a vertical projector so that it is going to cut the XY line. Since so end A is above HP, so that will going to be image will going to be seen as A dash. And since it is end A is in VP, so image will going to be on horizontal plane. It will be the top view. You can see both A dash and A, which has been shown here. Then he says the true length of the line is inclined at 30 degrees to HP. So from A dash you draw a line which is, by using the protractor, you measure an angle of 30 degrees and draw an inclined line. Then by using the compass with A dash as center, take the radius of 90 mm with A dash as center, cut an arc on that 30 degree line so that you are going to get this point B1 dash. Then join A dash and B1 dash with little bit thicker than the projector line. So this will going to be the true length line. Then draw a dash dot line in the front view. So this will going to be the locus of B in the front view. Then since this is the true length line, you write it as capital A and capital B. Then since you know the front view which measures 70 mm with A dash as center, take the radius of 70 mm and cut an arc on the locus of B in the front view. So that point will going to become B dash. Then join A dash B dash with a dark line. So this will going to become the front view. So we know the front view and also the true length here. So what we need to do is we need to find out the top view first, because we know the front view. So the top view line of B will going to lie on this end projector. So draw a vertical projector from B dash to the top view. Then we know that this is the true length in the vertical plane. So obviously that line has to be parallel to VP. So NDA is in VP. So NB1 dash, when it is projected onto the XY line, so that becomes B1 is also on VP. So AB1 is the line which is parallel to VP. Since it is parallel to VP, so you are able to get the true length here, which is AB. Then we know that the top view of the point B1 should not lie on here, but it should be on this end projector. With A center, take the radius of AB1 by using the compass and rotate it such that it will going to cut the end projector point and end projector line at this point. You are going to mark this point as small b. Then join A to B with a dark line. So once you get the point B, so you are going to get the locus of B in the top view. So you draw dash dot line here. So write it as locus of B. Now we need to find out the true length in the horizontal plane. So you make the line which is inclined to HP, make that line parallel to HP. With A dash as center, take the radius of A dash B dash by using the compass, draw an arc such that both A dash and B2 dash will going to be above HP by 20 mm. Since A dash B2 dash is the line which is parallel to HP, so you are getting the true length in HP. So then from B2 dash you draw a vertical projector such that it will going to cut the locus of B in the top view. So you are going to get this point as B2. Since A dash B2 dash is the line which is parallel to HP, So you are getting the true length here and mark this as capital A and capital B. Then join A, B2, A and B2 with little bit darker than the projector line. So by using the protractor, you measure an angle of true inclination with respect to VP, which is equal to phi, which is 39 degree when you are doing it in manual. When you are doing it in computer, it will going to be 38.94. So this is how we will be able to solve this problem in the sketchbook. Now we will going to try to analyze this by using step by step. Now in the first step, first we are going to draw the data which has been given. First you draw the XY line and mark 20 mm above HP and on VP, so A dash and A. And now we know the true inclination with respect to HP and also the true length. So draw 90 mm line with 30 degrees inclination. So you're going to get A dash B1 dash. So this is the line which is in true length because it is given in the problem. So you write it as capital A and capital B. Once you get this, now you get the dash dot line which will going to be the locus of B in the front view. Since you know the length of the front view which is 70 mm with A dash as center, cut an arc on this, you are going to get this B dash. So then join A dash B dash with a dark line. So the draw a vertical projector to the top view, wherein the top view of the point B should lie on this end projector. So we know that front view line which is going to be in true length. So since it is in true length, the top view of the line should be parallel. So from B1 dash you draw a vertical projector so that NDA is in VP. So B1 is also in VP. So with A as center, take the radius of AB1 and draw an arc such that it will going to cut the end projector at this point, small b. So join capital A to B with a dark line. So you are going to get the locus of B in the top view. So that is what we have done. So here you have rotated the point A dash B1 dash such that that B1 dash will going to come on this end projector so that it will going to fall on this. So you are going to get this point B. Once you get this point B, draw a horizontal dash dot line which will going to show the locus of B in the top view. So this is how you have been done in the first step. Next, in the other step, so once you get this, now we need to find out the true length in HP. So you make the line which is inclined to HP, which is A dash B dash. You make that line parallel to HP. A dash B2 dash, which is the line which is going to be parallel to HP. So that is what we have done with A at center. Take the radius of AB. So because you are taking the front view line which has to be rotated. So when you are rotating this, what happens in the image in the vertical plane also it will be rotated like this. So that this B2 and this B2 will going to be on the same line. So that A dash B2 dash is the line which is parallel to HP. Once it is parallel to HP, so you are getting the true length here. So when it is projected here, so that point will going to become on the locus of B in the top view. So that is how we will be able to, by rotating. So since we are rotating in the space, obviously the image in the vertical plane also is rotated when you look from the front view. So this is how we will be able to analyze this. So then once you make this parallel to HP and you project this point from B2 dash to the locus of B in the top view, so that join A and B2 which is going to be the true inclination with respect to VP. So by using the protractor you measure the angle which is 38.94 when you are doing it in computer, when you are doing it in CAD, and when you are doing it in manual it will be 39 degrees. So this is how we will can be able to analyze stepwise.